All right, guys, this is Business Analytics, lecture number 2, right? And it's going to be a double hour, so we're going to get 2 lectures today, maybe even chapter 2 a little bit. We went to slide number 8. I got to push the F5 button, right? Get the full screen hopefully working. Okay, computer 1. Hopefully it's going to get up and running. So we went to screen. Is it getting okay? Business analytics is about combining data and technology and software and some type of statistical analysis. Examples will be pricing. Example will be customer segmentation. It will include merchandising. It will include store locations and maybe analysis of data coming from social media. Business analytics started early on as business intelligence. Later on, it included information systems. It became the subject of operations research. That's how it was done 20 years ago when I was a student. It wasn't exactly analytics, but operations research was a major subject. And then it also transformed into management science. This is what business schools have been teaching mostly for 30 or so years. Management science back in the old days, pretty much as it is today, is just math. A lot of math, a lot of quantitative methods in business. And then they went into decision support systems. And finally, you got modern day analytics, a new subject, a new field of the last 15 or 20 years. It includes statistics, as I mentioned, some modeling and optimization, some business information systems, we also call them business intelligence systems, and we use basic visualizations, as graphics and charts, some scenario analysis, what if questions, what if we raise the price, what if we lower the price. We have some simulation and some data mining. What are the benefits? If used properly, skillfully, and well for big business, it can have big potential returns. Okay? And what are the challenges? The basic one is knowledge and understanding how the systems work, how the systems are used, how the system can be interpreted. The 3 major areas or fields within business analytics are descriptive analytics. You just describe the data, just show a picture, just see what it looks like. The second level is predictive. Not only you describe it, but you try to forecast what's going to happen next week or next month or next year. If you got a movie theater, by seeing how many people come at 3 and 4 o'clock in the afternoon, you should be able to predict how many people will show up at 8 and 9 o'clock during the peak hour of movie going. And finally, some prescriptive analytics, which basically tells you or is asking the question, well, what is optimal? What is the best way to go about it? So it identifies alternatives either to minimize or to maximize some objective. This minimum and maximum is best translated as we want the best outcome, as in the perfect outcome. The process is called optimization, and optimization gives you optimal values. The tools we mentioned last time will include data queries, data sourcing, some sort of a dashboard, data visualizations such as charts, some statistical methods, some spreadsheets, what if analysis, what if scenarios. And again, some more advanced techniques will be simulation, forecasting, data mining, optimization, and so on. This is number 8. Retail markdown decisions, skip that one. So, which are the main softwares? Number 1 is IBM Cognos Express or Cognos software. I think I mentioned last time when I worked in a corporation, Cognos back then, 15 years ago, was the best of the best. I guess even now it will be still the best. It provides what's called analytical cubes. We're not going to get into this at this point. SAS is the major software for statistical analysis, and later on it has grown into data and business analysis and into business analytics. I don't know much or anything about this software. Never heard of it. It's got to be something new and novel. So, what you need to understand in general is the difference between data and information. Data relates to certain numerical or textual fact. Numerical will be 170, 155, 153, whatever the height of the student is. Okay. Textual will be male, male, female, 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 male. Okay. This is simple textual. Another textual, driving, motorcycle, motorcycle, car, car, SUV. Okay. Different type. That's data. Information will result from some sort of analysis. For example, data will be, for example, teacher evaluation. They say good, 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 bad, good, good. The information will be 95% of the students think that the teacher is good. So we can generalize or conclude that for most students, the teacher is good. So information gives you something more general, something more fundamental, such as, is the university good or bad? A different type is you get data on different universities, you rank the universities, and then the information is, oh, this university is scoring #1 in the country of Cambodia. All right. So being #1 is a valuable piece of information. Okay. It's just one piece, but it's valuable. Next one, where we get data sources. We get data sources from annual reports, as in annual accounting reports. Number 2, from accounting audits. We can get financial profitability. So, how do we get financial profitability? From the quarterly or accounting report, you get the profits numbers and you compare them to the capital, the equity number, and you get the profitability. Well, if you do this quarter by quarter by quarter by quarter, or year by year, you get the trend, the economic trend. You can do some marketing research. You ask people, hey, did you like the movie? How did you feel about the movie? Or, is the phone working good? Are you happy with the battery life of the phone? Whatever the questions are. You ask people, you collect data. The process is called data collection. I was just working over the last 30 minutes on data input. Data input will be, well, what I just did about 5 minutes ago was spread the sheet among you, the attendance sheet. Everybody signs your name, okay? Well, that's the data collection part. Then I'll go into the computer system, and for each name, I will say present, present, absent, present, present, absent. That's data recording, okay? And then the last part is data analysis. Student A, attendance 20, absence 0. So that's available information. In other words, attendance rate of 100% is very good. Attendance rate for the next student, 93%, is overall good. And attendance of 5%, not very good, right? So that last piece is information, the attendance rate. And each attendance is data. Oh, that's good enough. Data set. Well, what is a data set? It's simply a collection of data. One simple data set. Where's the sheet? There it is. Simple data set is this sheet. It's got a name and a signature. Signature meaning present, and no signature meaning absent. Okay. This data we call, if you remember, well, it's called binary, meaning the value is 0 or 1. There is no other value. Present or absent. Okay, 0 or 1. So that will be a simple data set. More complex data set will be like this. Student A, whatever the ID is, and you got more data. Height 166. Weight 56. Age 17, okay, 19. Sex female, okay. Nationality, I don't know, Cambodian. Next, income, whatever number, okay. So you can have more and more and more variables for each particular person, okay. And then you have a database. And database will be essentially a number of data sets, and these data sets can be related to each other. Maybe they're related to each other by student name or by student ID number. Usually, all universities issue student ID, and the ID is unique so that they can relate different databases, like class database to classes to enrollment, and then the enrollment relates to student ID, so you can get the student attendance for each class, okay? Then it's going to be related to grades, so you get the student grades for each class, okay? So you begin to relate different things, attendances with courses, with grades, with whatever else you need to relate. So databases is a collection of related files. A file we think in terms of a simple table. So it's a number of tables can be related to each other in some way. Next, example, here is a sales transaction database file. Okay. And it just tells you, hey, this is the customer ID, 10,001, 10,002. The region, Southern, Eastern, Western. Well, when I was working in the US corporation, it was indeed, it was in a sales department. You had a Eastern region, and a Southern, and a Western region, so, and a Central region. So you want to separate it out by regions. Well, when there is a purchase, usually there's a payment type. And the payment type could be cash, credit card, PayPal, whatever the payment types are possible. In this case, they got only 2. And then each transaction will have its own transaction code, okay, so that there is no confusion what is the transaction. Finally, how do you get the source of the sale? It could be walk-in, customer shows up, okay, and walks in. It could be through the website, or somebody just sent an email to ask, okay, that could be quite realistic. And of course, you record the amount, you record the product that they were interested in, DVD, book, whatever, and you record the time of day. And that's a sales transaction, in this case, file, just one file. So, Data could be small, this is what we use, and big, like very big databases. And these are massive amounts of business data, usually from a wide variety of sources, much of which is available in real time. When I was 20 years ago, yes, 1996, graduate student at the Ohio State University, I had to have some very good skills to use a very large database which had 20 years worth of weather data, the temperature, the wind, whatever the weather was, on an hourly basis. So you can think 20 years, and for 20 years you have 365 days, and then for each day you got basically 24 observations of a large number of variables, okay? So basically, the guy is saying, well, tell me and this is in a number of different places in the state, for maybe like 20 different places in the state of Ohio. So this is what I was doing back then. That was, in this type, it's going to be, instead of business intelligence, will be weather intelligence. So the guys basically asked me a simple question: which way is the wind blowing in the afternoon? In other words, I got a wind, I got the wind speed, and I got the wind direction. I got to average out and say, okay, in January the wind blows at that kind of direction, in that kind of speed, in the afternoons. Okay, well, which way is the wind blowing during the night? For example, when you're building a little farm for animals, you want the door to be on the back of the wind. So if the wind is blowing, it should be blowing from the back. So he's asking, well, at night between 2 and 6 o'clock, what is the direction of the wind in the winter? So I gotta select, give me the winter months, give me the night hours, and now give me the direction of the wind and the speed. Okay, so these are simple questions which were back then used in agricultural engineering, and they could be used, similar questions, for business. And that's big data. It can take many hours. Again, now this data set is not very big, but back then, 20 years ago, computers were very powerful. So back then, it took a lot of time and a lot of effort to crank such data. Today, such data is usually associated with web activity, as in activity on Facebook, okay, with 1 billion people in the world spending 5 or 10 hours and clicking thousands of links all together. And whenever you have a data set, and data in general, you got metrics and measurements and measures. So what is a metric? Well, it is simply a unit of measurement that provides a weight. So somehow the metric of a height, okay. Well, the height usually will be measured in meters or centimeters. So measurement is the act of obtaining the data. So usually stand up, you put the height and say 171 centimeters, okay. And then measure will be the numerical value. The numerical value of 171, numerical value of 178, right? Numerical value of 166, okay? This is just the number, okay? So the measure itself is the number. This is the process of getting the data, okay? This is the number. And the metric is, well, what do you measure? What's the unit? Unit is centimeters. Metrics can be discrete, as in colors, okay? Color, black color, white color, blue, okay? Discrete metric can be male, female, okay? Discrete metric can be Asian, European. We call it, if it's a race, we call it Caucasian, African. Okay, there are just 3 or 4 races out there. Okay, so discrete means it has takes only a few values. Example of another discrete will be operating system of a phone. And it could be Windows, Android, and the iPhone operating system, right? Basically 3 or 4 operating systems. These are discrete, okay? And continuous will be, let's say, the height. Could be anywhere from 130 to 2 meters, okay? Or the weight could be, or miles, or kilometers, or whatever. Data can be categorical. Usually, discrete data is categorical. Again, categorical will be clothes, clothes type, shoes, clothes type, socks, clothes type, pants, clothes type, belt, clothes type, shirt. Okay, this will be type of data, categorical. Ordinal will be additionally also somehow ordered. Example, first year student, second year student, third year student, fourth year student. That will be ordinal, okay? Then you have interval, okay? They are ordinal, but there are also equal distances. A good example of interval data where the interval is identical would be days. The first of the month, the second of the month, the third of the month. Each day is exactly the same as the previous day, okay? So the day, the date, the hour will be some sort of interval. And finally, ratio data. It will have will be continuous and natural zero. For example, height will be a ratio, 171, 150. For a child, it could be 50 centimeters for a baby. Okay, ratio data will be prices. Price could be $0, could be $3, could be $30, could be $3,000. Okay, so these are the main types of measurement scales. I think examples should be coming soon. Yeah. Okay, the purchase order, whatever, fast, high, aerospace, healthy, whatever. That's categorical. It's the same as the shoes, the pants, the shirt. Okay, it's exactly the same. Number 2, order number. Order number 1, number 2, number 3, number 7, number 27, number 37. Here, it would be ID number 1404-0105. Another number, 1404-0110. It's just number, okay? That's an order. It's still ordinal. Item number will be categorical. There is no real meaning to 2319, okay? It's kind of like 5462. There's no genuine meaning. The number doesn't mean anything particular in terms of scale. There is no scale. If you're a height, there is a scale, okay? But here, there is no scale. Again, item description. Pressure gauge, O-ring, shielded cable. These are all categorical. What's next one? Item dollars. Okay, now sorry. Cost. Item cost. $4.25. $4.25. $1.05. $1.10. $90. These are ratios. Okay. Next, how many units? You buy 100 units or 425 or 22 units, whatever the units are, they are definitely ratio. Okay. Cost per order. How much the whole order costs is again straightforward ratio. A&P terms, whatever is the account payable, how many months you gotta pay. And then they got, well, what's the order date? Well, that's the interval. The date is interval and arrival date. That's also interval. You see, order date August 20, arrival date August 26. So it's just a simple example. In business, some data are very reliable and some data are not so reliable. Okay? It depends on how you got the data. Okay? Example, how many of you like my teaching? If I'm asking the question, many may raise the hand, but they raise it just because I'm in the room. It's very different when it is anonymous and it's on the website and I don't see who says what, right? So, when you try the one way, the first way, raise your hands, it's going to be very unreliable. But on the web, if it's anonymous, it's more reliable. Doesn't mean perfect, but the reliability is higher. Okay? It's accurate and validity. Data, correctly measures. If we got a little scale here and everybody steps and we record it, that's going to be fairly reliable data. Okay? Everybody steps, 60 kilogram. Next one, 55 kilogram. Next one, 51. Especially if you use the same scale, it's going to be both reliable. Now, there may be 1 kilogram error for each one because the scale was bad, but overall, it's going to give you relatively reliable data. Okay, and they got here some stuff. Model. What is a model? A model is an abstraction of the real world. It is a simplified version of the real world, not a complete. You only take what is most important. So, it is an abstraction or representation of a real system or some idea or some object. It captures what is most important. We say what is only essential. In other words, what are the essential variables? Okay. And it can be either written or verbal. In other words, you can have it written verbal, you can have it somehow visual as a picture, or it could be some sort of a formula. And verbal description. The sales of a new product, iPad or whatever, follows a common pattern. And here is a simple description. Rate of sales starts small, is early adopters. In other words, when you start early, very few people take the brand new product. They don't know it. It's very expensive. They don't know how to use it, but they are curious or eager to get it. Okay. And then begins to grow at an increasing rate over time. In other words, early on it's going to start slow, then it's going to accelerate, and when most of the people get the product, it's going to slow down again. So it's going to have like a S type of a curve. And probably there's got to be a picture coming of this increase and then slow down. So, early on it's slow, it accelerates, and here it decelerates and we say tapers off. It's a simple model of market that's called saturation. Or it could be a mathematical model, some kind of a formula. Okay, in this particular case, it's some exponential function. All right, what is an influence diagram? Well, it shows you what affects what causes what. So, it tells you representation of a model that shows that how the elements influence each other. And it's best to see in a picture. Total cost is affected by fixed cost. Now, the fixed cost affects total cost. Variable cost affects total cost. Well, now the question is, what's fixed cost depend on? What variable cost depend on? Well, in this particular case, variable cost depends on unit variable cost and the quantity produced. So you develop a more complex model, but it's the same thing. It's an influence diagram. It's simple, easy, pictorial, we call it graphical representation of what affects what? It could be written as an equation. Total cost is equal to fixed plus variable. And then variable cost is equal in terms of unit variable times the quantity produced. And then you rewrite the formula. And you can possibly use variables. TC for total cost, F for fixed cost, V for variable unit cost, Q is the quantity. And it becomes TC, which is total cost, equals fixed cost plus variable cost times the quantity. Okay. It's a simple, easy, straightforward presentation. Next one. Decision models. Decision model, again, is a logical or mathematical representation of a problem, okay, or business situation. A simple decision model was, when I was teaching in Thailand, that a minimum of 80% attendance, class attendance, is required. So a simple decision model is we enter in the system the attendance, okay? If attendance is below 80%, the student gets automatically F. The decision is made by the system, by some rule. Similarly here, the decision system in specifically decision model would be your grades. You get 95, you get 93 points. Somebody in the back gets maybe 55 points, right? Others get 80 points. So based on the points, a decision system will design or will designate a grade. You get A, you get C, you get B, you get F. Okay, the system will be designed. Now, maybe we can possibly change a little bit the grade, but overall the system will provide a decision. Well, this is what's called a decision model and a decision support system. Decision support system will be a system which incorporates the model and helps you make a decision. All right? Question? No. So, what is the nature of decision models? Very simple. There's an input and there's an output. The input is score. Score 78, score 83, score 93, score 55. And what is the output? Grade A, grade B, grade A, grade C, right? Grade D, right? So, the output will be a measure of performance. In this case, it will be your academic performance, okay? And this will be, the input will be basically the percentages, okay? The score. So this is the score, number from possibly 0 to 100, and this is a grade, number letter A, B, C, D, or whatever F the grading system is. And it could also be used in some sort of analysis, okay? Here, the input is photo. How many units we decide to produce. So, the total cost is 50,000, which is fixed, plus 125 times the quantity. But if you outsource it, you pay 175 per unit. So, in this case, the break-even point, usually in business, break-even means that the revenue equals the cost, or that the profit is 0. In this particular case, the break-even is that the cost of manufacturing equals the cost of outsourcing. So, if you have, let's say, only 500 units, the question is, which is more economical? It tells you, for 500 units, the cost is, red one is, what's the red one? Red one is outsourcing, and blue one is manufacturing. So for 500 units, the manufacturing cost is higher, the outsourcing cost is lower. It is more economical to outsource. Above the break-even point, the cost of outsourcing is higher, the cost of manufacturing internally is lower. It is economical to manufacture at home. So below 1,000, you outsource. Above 1,000, you make it homemade. Okay? Well, that's a simple decision model of outsource versus homemade. Okay? In this case, it's based on the break-even point. Next one. There could be a sales promotion decision model. Don't want to go through that. You have some examples over here. Well, example over here is $6.99, $6.49, whatever the weeks are. And then I got a coupon. Coupon is have coupon, don't have coupon. So coupon, yes or no. Yes is 1, no is 0. Advertising will be similarly binary. No advertising is designated as 0. With advertising is designated as 150. In other words, you spend $150 on advertising. So it's possible to have coupon and advertising, or no coupon, no advertising. Okay? Or with coupon, no advertising. You additionally have how many units. How many units you sell in store 1. And then how many units you sell in store 2. Then how many units you sell in store 3. And then you design some sort of a model. And the model would be looking like this. 500 minus 0.05 times the price, plus 30 times the coupon, plus 0.08 times the advertising. So it tells you the effect of price on the quantity, the effect of the coupon on the quantity, in this case it's 30, the effect of advertising on the quantity of sales, and there is some price times advertising is called interaction effect. I think it's coming soon. Every model's got assumptions, okay? And assumptions are sometimes called simplifying assumptions. So, assumptions are made to simplify the model. It makes it simple and it makes it easy to understand. You take what is most important, we call it essential, and all the other things are not so important, okay? You make it to be easy to solve, easy to analyze, easy to predict. Again, when you make a simplifying assumption, the model is not perfect. You want the model to be good enough. You don't need perfect, but just good enough, as long as it is simple. So, you make an appropriate model. In other words, the appropriate means good enough. It shows, it works close to reality. Okay. And here, economic theory tells us that demand of a product is negatively related to its price. So a simple model is that as price goes up, the quantity demanded goes down. Like this. As the price from 80 goes to 90, the quantity goes down by, in this case, 100 units. From 90 to 10, price goes up by 10 units, the quantity goes down by 100 units. And it's a simple formula. In this particular case, it is a linear model. Linear means that it's a straight line. The alternative may be that the line is curved, in which case we call it curvilinear, sometimes non-linear. Well, here's an example. This is not exactly a straight line, but there is a curvature over here. and it's called non-linear model. Okay? There is some interaction or maybe some squareness or whatever else. There's usually a formula. In business, there is uncertainty and risk. Uncertainty, you don't know exactly what's going to happen, and you cannot predict the odds. You can't tell the probability. For example, we expect soon to have a second Asian financial crisis, and maybe a currency crisis, an economic crisis. But it's hard to predict. What's the chance of happening it this year? Maybe 1%, maybe 5%, maybe 10%. With risk, you're able to predict probabilities. You're able to give a reasonable chance. For example, we know that the chance of, let's say, example from life insurance, someone from this classroom dying by the end of the year will be 1 in a million chance. Yes, it could happen 1 out of a million times, yeah. Well, with the chance of or risk of motorcycle accident, maybe 1 in 100. In other words, 1 student out of 100 by the end of the year may have a motorcycle accident. And we can, based on probabilities, it's very easy to say, well, the chance is between 1 and 2% for 100 people, right? So these are bad examples, but still examples of how you can measure probability. We know probability of a lot of accidents. We know probabilities of rain, probabilities of flood. We don't know probabilities of earthquakes. Also, it's very difficult to predict probability of wars. Even more difficult to predict the probability of civil wars. Okay? So these are difficult to predict. Next one. Next one. Oh, this one is. Next one. Models can be, again, descriptive. They show you what the reality is. Models can be prescriptive. And they tell you how you get the best solution. In this case, we're looking for what is called optimal solution. Optimal means either maximum of something that you desire, like the maximum profit, okay, or the minimum of cost, okay. So, optimization is the process of finding optimal values. Optimal values are values that we desire, that we want to achieve, like higher profits. And then you have what's called objective function. Objective function may be higher profits, okay. Objective function may be high GPA, so that your GPA is very high. So you may want to maximize your GPA, okay? And there are certain constraints. What is the constraint to GPA? You have only 24 hours a day. Time is a major constraint. You can't study for 20 hours a day. Well, maybe one day, but not the next. You gotta sleep, you gotta eat, you gotta play Facebook, right? In other words, there are other things in life than just studying. You cannot possibly study 24 hours a day. Maybe you can study 7 hours, maybe you can study 11 hours, possibly 13 hours, okay? So the constraint here is limitation of, or restriction of time, hours, okay? And finally, you get the optimal solution, which is the best value, or the value where the decision variable reaches the highest point, or the lowest point, or maximum point, or minimum point, depending on what the objective is, okay, sometimes. They have some prescriptive pricing. Want to take a break, huh?
Yes.
10